All right, welcome to your semester one practice exam. I'm going to go through the 31 problems in the exam, not all at once in shorter segments, and just kind of talk about how to do them. These 31 problems are exactly the same as the 31 problems that are going to show up on your actual exam, except for maybe with some minor changes, numbers changed around a little bit, just a few little things, all right? For each problem, I'm going to let you know where in the book you can look for more information. Let's start out here. Write the negation of the statement. Well, the negation of the statement is just the opposite of the statement. So the negation of the flower is red is the flower is not red. The negation of the cat does not have spots is the cat has spots. Right? So the negation is just the opposite of the statement. You'll find more information about negations in section 2.1. Section 4.1 would have more about this here. Number 3, write a rule for the translation triangle ABC to triangle A prime, B prime, C prime. Now when they talk about a rule, they want something like X comma Y maps to something. So let's see. Well, it looks like the X coordinate would tell us how far left or right this is. So the X coordinate for A was originally 1, 1. And for A prime, it's 0, 1. For B, it was, the coordinates were 4, looks like 10. Oh, hold on there. That's not a 1, that's a 2. Now, and for C, the original coordinates were, oh, that's a 2, 2. We got to be careful there. For C, the original coordinates were halfway between 8 and 12 is 10 and 4. Ooh, I think I was catching that. The scale is not going up by ones. It's a trick. So the X coordinate went from 2 to 0. Oh, here. For C prime, it's 8. Let's see. 4. And for B prime, it's 2, 10. So here, the X coordinate went from 2 to 0. Here it went from 4 to 2. Here it went from 10 to 8. So it's X minus 2. Okay? Now don't fall for the trick I almost fell for of just marking these as you see them, because careful with the numbers. 8, 10, 12. I'm going up by 2s. The Y coordinate was originally 2, and it stayed 2. 10, and it stayed 10. 4, and it stayed 4. So you could put Y plus 0 or Y minus 0, or you can just leave it as Y. Okay? So again, this is going to be a multiple choice question, so you're looking for the right rule. It'll be right there. All right, and again, that's from section 4.1. All right, name the property that the statement illustrates. Let's see. If MN, segment MN, is congruent to XY, and XY is congruent to RS, so notice that XY occurs in both of these, and so MN is really ultimately congruent to RS. And this is the transitive property of congruence. There's also a transitive properties for numbers, so make sure you keep those straight. This one's about congruence. Your other properties are, well, here's another one. EP is congruent to BE, and BE is congruent to EP. This is the symmetric property of congruence. The other property that would show up would be the reflexive property of congruence. And actually, I should add on segment congruence, because we're specifically talking about segments. It'd be called the transitive, symmetric, or reflexive property of angle congruence if we were talking about angles. And for the reflexive property, it's just something like MN is congruent to MN. Every segment is congruent to itself. If you deal with angle congruence, then it would be a statement like, angle A congruent to angle A. The symmetric property would be, angle B congruent to angle A, then angle A congruent to angle B. So it just goes both ways. And for transitive property of congruence, something just like this, except all with angles. All right, I think that's enough for our first video. First 5 problems. Let's pause.